Hello and welcome to Empowered Learning. This particular lesson will be on how to properly graph the inverse sine function. So to start off, to graph the inverse sine function, we first need to know what the sine function looks like and what we're considering when we come up with the inverse sine. So the first thing that we know about inverse functions in general is that they're what we call one-to-one functions. So a one-to-one function is a function to where each x value that it has also has a unique y value. So in graphical terms, what that means is the graph of whatever function that we're dealing with has to pass what we call the vertical line test as well as the horizontal line test. The vertical line test tests to see if the graph is a function indeed, and then the horizontal line test tests to see if we were to invert the graph, would that be a function? And so we can see here for the sine function, if we start to draw vertical lines in it, that it definitely passes the vertical line test. However, if we draw horizontal lines, we see that the graph of sine x does not pass the horizontal line test. So what this means is this particular graph is a function, but it is not what we call one-to-one. So with a lot of trig functions, since they are periodic, what we have to do to create an inverse function for it is to restrict the domain. And so what we're going to do to restrict the domain is find a piece of the function sine x that looks to be one-to-one. Now it turns out if we look here at minus pi over 2 at x, and then we go to x equals pi over 2, the portion that goes from minus pi over 2 to pi over 2 ends up being a one-to-one function. So this piece starting here at this point, stopping here at this point, and everything in between. And so we can see that it is indeed a one-to-one function because it passes both the vertical line test as well as the horizontal line test within those particular x values. So we know that we can use this particular piece to create our inverse function. Now it turns out that from a graphical perspective, whenever we invert a function, what we're really saying is let's change the x and y values, let's interchange them, and then graph that. And then that's what the inverse function would be. So as you see, we have some key points here for sine x. So if we wanted to do the key points for inverse sine x, all we would do is interchange these points. So instead of it being minus pi over 2 negative 1, it would be minus 1 minus pi over 2. So we just interchange. And similarly, instead of having negative pi over 4, negative 1 over square root of 2, now we have negative 1 over square root of 2 and negative pi over 4. And of course, the point 0, 0 will stay the same. And then since sine is what we call an odd function, we know that if we flip over here for pi over 4, 1 over square root of 2, then that just flips and everything is positive. And so same thing for this last point. So we see we have our key points for the inverse sine function, and so all we would need to do is to invert our x and y axes and then graph these. And so that's what we're going to do next. All right, so now that we've used our graph of sine x in order to find out what the inverse sine x key points would be, we've replaced our graph of sine x with the particular xy plane for the inverse sine function. So now all we're going to do is plot our points and then see how the graph ends up looking. So as we see here, our first point is negative 1 negative pi over 2. So that would be about right here. And then we have the next point, negative 1 divided by square root of 2 for the x coordinate and negative pi over 4 for the y coordinate. So for this y coordinate, that would be about halfway in between. And negative, go ahead and write this down, negative 1 over square root of 2 is about negative 0.7071. So if this is the halfway point here in between 0 and negative 1, then we would say 0.7 would be about there. So we'll go ahead and plot our other point. Then we have the point 0, 0. And then we have positive 1 divided by square root of 2 pi over 4. So again, halfway between 0 and pi over 2 on the y-axis would be about here. And if this is halfway in between 0 and 1 on the x-axis, then 0.7 will be about right here. So we'll plot that point. And then the last point will be 1 pi over 2. And so if we just follow that general profile, we see that our graph ends up looking something like this.